To write a parabola in graphing form, we're going to utilize the strategy of completing the square, which we've used before with parabolas. The difference now, of course, is that our parabola equations are a little bit more complicated. In this case, we're dealing with y squared, x, all sorts of terms mixed up. So in order to complete the square on this one, we're going to have to first organize our terms. Since y is the term being squared, we're going to keep that. We're going to keep the other term that has a y, since they're sort of similar. And we're going to move to the other side of the equation anything that's not one of those letters. So since those are the only two y's, then everything else is going to move to the other side, giving us positive 8x minus 12. Now in order to complete the square, as usual, we have to focus on the number next to, in this case, the y, since that's the squared term. Since that number is 4, we have two steps to follow. Divide by 2 and square. 4 divided by 2 is 2. 2 squared is 4. So we're going to add that number not just to the left, but also to the right side to be balanced. Anytime we add to one side of the equation, we have to add the same quantity to the other. Now on the left side, y squared minus 4y plus 4, that's a diamond problem. We need to find numbers that multiply to 4, add to negative 4. Since those numbers are negative 2, literally the same number twice, we're going to write that as y minus 2 squared. So just basic factoring there. On the right side, we're just going to combine like terms. 8x minus 12 plus 4 would give us 8x minus 8. If we remember, the general form of the parabola equation definitely has the parentheses squared, but it also has a fraction right here. That fraction is going to come from looking at the other side and noticing the fact that these two numbers have an 8 in common. If we divide both sides of the equation by that common 8, that would give us the fraction over here. Division is fraction, so we'll just write it that way. And that'll mean that these terms get reduced a little bit. So we're going to divide by 8 since it's common to both terms. And we're going to divide by 8 on this side. To make it not look so awkward, we're just going to immediately turn it into a fraction, 1 over 8, since that's the same as dividing anyway. Now that our equation is generally simplified, let's write it out in order. Our graphing form would be 1 over 8, y minus 2 squared, equals, and those terms divided would give us x minus 1. Based on just a few pertinent pieces of information, we know that the vertex of this thing would be 1, 2, x, y. In making this sketch, we also know that since we are horizontal, the y is being squared, and since the fraction is 1 over 8, that came from the 1 over 4p thing, the p-value must be 2, since 4 times 2 would give us 8. So since we're horizontal, and we have a positive 2 p-value, we would go 2 units to the right. There's our focus. From the vertex, we could go 2 to the left. That would be the equation of our directrix. And so even without much information, we were still able to sketch the whole curve. Now in the questions at the bottom here, these are questions that are giving us key pieces of information and just asking us to fill in the gaps. So just as we did above, we're given only a small bit of information, we could sort of figure out everything else. We're going to do the same thing here. Since they're not giving us an equation, we don't have to worry about completing the square. We're just going to make sure that we've got the basics. For example, we've got a vertex given to us. We know that vertex is going to be part of the equation, so that's going to be important. That's why I draw that little box around it. If we're at 1, -1, which is here, we've definitely got a place to start. Now it also tells us that the directrix is at x equals -3, which implies that the directrix will pass through the x-axis at -3, which means it's a vertical line there. Now since we know from doing parabolas that the distance from the vertex to the directrix is the same as the distance from the vertex to the focus, that implies the focus must be around here somewhere, because if we went left to get to the directrix, we had to go right to get to the focus. Since we went 1, 2, 3, 4 units to the left, that implies we'll go 1, 2, 3, 4 units to the right, and that must be our focus. Notice lined up with the vertex. The coordinates at that point appear to be 5, -1, just in case we needed to note that. But since it's only asking us for the equation, I think we have enough information. We know the vertex is at 1, -1. We know it's horizontal in shape. And we know that the distance from the vertex to the focus, or the vertex to the directrix, is 4 units. That's what we call the p-value. So in terms of our equation, using the formula from our previous set of notes, our equation will start with x, since it's horizontal. In this case, the coordinates that we need to use are -1 equals. Since that distance was 4, our fraction must be 1 over 16. Remember, that's 4 times the distance. Parentheses y plus 1 squared. Notice we use plus 1 because of that y coordinate. In the second example, we're going to do basically the same thing. Given the information that we have, figure out the rest. The vertex here is 1, 5. The focus is 1, 7, practically running out of space. Now again, we'll have to note that the distance from the vertex to the focus is the same as the vertex to the directrix. So since we have a distance of 2 units between the vertex and the focus, and since we went up to get to the focus, we know we'll go down 2 units to get to our directrix. If we look carefully, that means our directrix would be at y equals 3. Since it's only asking us for the equation, we have all the information we need. The vertex and the p-value, which in this case again was 2, since we went 2 units between focus and vertex. So in terms of our equation, we're dealing vertically, so we'll start with y. The y coordinate, of course, is 5, so y minus 5 equals the fraction, 1 over 4p. So since we know our p-value, 1 over 8, and it's positive, we're going up, parentheses, and as we're taking a look at our parentheses, we have x minus 1 squared, again, because of that y coordinate. In the last example, we have the focus is 0, 4, the directrix x equals 2. So this we'll have to pay very close attention to. When we're dealing now with this focus, we have 0, 4. And as we're dealing with the directrix, x equals 2, that would be passing through the x-axis at 2, you'll notice in this case that there's that little gap. We know that the vertex has to be exactly halfway between the focus and the directrix, which implies that the vertex must be right here. Looking at the graph, we can tell that the coordinates of that vertex are at 1, 4, which would make sense. And that's actually the set of numbers that we need for our equation. The other numbers that we need for the equation are the ones that help us with our fraction, the 4p thing. So since we can tell that the distance here is 1 to get to the focus, and since we can tell that it's facing to the left, since that focus is leftwards, we know that's going to be a negative a value. So backing up for a second, we're horizontal here, so we're going to start our equation with x. In this case, since the x coordinate is 1, minus 1 equals, now let's think of our fraction. The p-value is 1, it's negative because it's facing left, so that means our fraction is negative 1 over 4. Including then the next part with the y, that might y minus, in this case 4, squared. So our equation all put together will ensure that this is facing the correct way with the y squared, make sure it's negative to show it's going left, and to make sure our vertex is accurate, positive 1, positive 4.